there, Julio Leonardi, and I'll be presenting our project on behalf of Group 127. So to start off first, we would like to do a demonstration on the back end. This project includes a GUI, which is done in SFML, but first I want to show how things are done in the back. So the purpose of this project is to first create a graph with like synthetic data, meaning that are supposed to represent bank transactions. And then we use two distinct cycle detection algorithms to find the first, like, to report what's the first cycle they find and report back with the source node. So to start off, here's the constructor for a transaction graph, which will then be fed to both of these things. Like this first parameter is the node, number of nodes. Second is number of edges. Let me run this real quick. As you can see, when like both of them return -1, it means that there was no cycle found. So as a result, like this pretty nifty code I wrote here explains that we in fact did not find a cycle. But let me increment this to 100 and this to 500. The chances of there being a cycle just like increase exponentially. Now let me run this again. Yep. So what the program does is that it reports back the source node where it finds the first cycle. And yeah, that's how the backend works. Now for the cool stuff, the GUI. So we worked on this SFML thingy. It uses a template we found of GitHub right here. And let me run it real quick. So yeah, this is like a GUI. It's pretty basic. Use the number of nodes, number of edges. And what it does is that it runs both at the same time and tells you how fast each of them were able to complete. And the purpose of this is that this way we can compare both algorithms, Tarjan's algorithm for cycle detection and the union find algorithm, or at least our implementations of them. We can test them against each other to see which one is more efficient. Now, with the GUI, you can tweak these values. Let me do our example where there's 0 edges to show that it's, yeah, graph has cycle. No, absolutely not. It's impossible. So now that's a pretty big number. We were supposed to do something that could be able to handle at least 100,000 entries. This one does up to 500,000. I've tried with other values on top of that, and we run the risk of Stack Overflow. I'm not working with dynamic memory, so yeah. See, it takes way longer now to find the edges, and like you can keep on pressing this. I'll keep on giving you results. So the purpose of this was to like apply to bank transactions in order to find money laundering cycles. And yeah, that's why we called it fraud patrol. GUI doesn't really reflect this. It's supposed to be like cosplaying a financial system, but there it is. It works. It was a pain to work with SFML, but we all did it together. So yeah, it's cool.